So let me zoom it and make it full screen. Okay, so here we want to send say 50 packets. Let me make sure I've started the recording. Okay, yeah. So we want to send 50 packets, and again the ones I have marked in red are the ones that have been dropped. So 10, 25, 34 and 45 are the packets that were dropped. So with this setup, we are going to see how many round trip times it takes with each of those three mechanisms. So let us start with AIMD. So in AIMD, we send one packet in the first round trip time and two packets in the next round trip time. So we do additive increase. So increase it to 3, so 3 packets. Then 4 packets in the next round trip time. Now packet number 10 gets lost. So what we do in AIMD is we reduce to half the previous congestion window size and continue with additive increase from there on. So in the next round trip time we send packets 10 and 11, and then we increase by 1, so 3 packets, then 4 packets, 5 packets, then 6 packets. Then we there's a packet drop, 25 gets dropped. So there are 6 packets in this congestion window, so you reduce by half. So the next round trip time is 25, 26, 27, so 3 packets, and then 4 packets, then 5 packets. Now packet 34 gets dropped, so we reduce the congestion window by half of 5, which is 2 packets. 34, 35 make it, then 36, 38, 3 packets, then 4 packets, then 5 packets, then 45 gets dropped. So half of 5 is again 2 packets, then 3 packets. Then you could really send 4 packets in this next round trip time, but you want to send only up to 50 packets. So that's why you send just the 50th packet in the last round trip time. So again, you will be given this information. If you look at the previous slide, you are given how many packets we want to send, 1 to 50, and these are the sequence numbers for the packets that get dropped, and packets get successfully delivered in the first retransmission attempt. And you're also given that packet size is 1 kilobyte, and each round trip time is 100 milliseconds. So for the exam, I plan to give each of you a different number. For example, I may give one person 50 packets and may indicate some packet numbers that are dropped. For another person, I may say 60 packets and may indicate some other set of sequence numbers for the packets that get dropped. And I could also change the value for the round trip time and the packet size. So these are the variations I plan to make and post the exam soon. So that each person will work on their own data set and should not be doing any copying. Okay. Even if I post everyone the same question, I don't expect anyone to do any copying. So you should be on your own and submit your own answer. All right. Okay. So the throughput is 50 packets in 19 round trip times. So each packet is 1 kilobyte. So as I mentioned last time, 1 kilobyte is 1024 bytes, and each byte is 8 bits. So 1024 bytes times 8 bits per byte divided by each round trip time is 100 milliseconds. So of course you should be able to convert milliseconds to seconds and do this math. So it comes out to be 215,578 bits per second. So once you decide your number of round trip time, everything's number of RTTs, everything else will just follow automatically. So larger the round trip times, the lower the throughput, and vice versa. Okay. So any questions so far before we go to the other two algorithms? I hope everyone can see the full screen I have made now. So the reason why I keep it like this, because I could see if any questions are being typed. So if once I make a full screen, I cannot see any questions you type in between. That's why I come back and I'm asking any questions before we proceed. Okay. All right. So let us continue. We'll do the same data set now for slow start. So the start with one data packet, then double it to 2, double it to 4, then double to 8. Now packet number 10 gets dropped. So that is the congestion window. We had 8 packets, so the congestion threshold should be half of the congestion window, which is 4 packets. But in slow start, we go all the way to 1 packet and then do an exponential increase until the congestion threshold. So the next round trip time we do 1 packet, and the next round trip time we send 2 packets, just double of this, then double further 4 packets. But that is now our congestion threshold of 4 packets. So on the next round trip time we do additive increase. So 1 more than 4 is 5 packets. Then the next round trip time we do additive increase again. So 1 more than 5 is 6 packets. Now packet number 25 is dropped. So the congestion window is 6 and the congestion threshold is half of 6, which is 3. So when we do slow start, again we go all the way to 1. So you just send packet 25, then double it, so 2 packets. Now you notice the congestion threshold is 3. So that means we cannot again double this from 2 packets to 4 packets. So we can set it to the congestion threshold. So we cannot double, but we can set something less than the double value. So if you double it, it is 4, and we cannot double it because the congestion threshold is 3. So that means we ramp it up all the way up to the congestion threshold to 3, and then from there do additive increase. So now again packet 34 gets dropped. So the congestion window is 4, the congestion threshold is half of that, which is 2. So we sent this packet 34, double that, so 2 packets. We have reached the congestion threshold, so you can do only additive increase. 3 packets, then 4 packets, 5 packets, again 45 gets dropped. So congestion window is 5, congestion threshold is 2 packets. So 45 just sent and then double it, and then you reach the congestion threshold. So you have to just do additive increase. So you can send 3 packets in the last round trip time. So it takes 21 round trip times with slow start alone. So 50 packets times 1024 bytes, because 1 kilobyte times 8 bits per byte, divided by 21 round trip times, and each round trip time is 100 milliseconds. So if you do the math, it comes to like 195,000 bit per second. Okay. So again, you can see even in this example, it takes 21 round trip times for slow start compared to the 19 round trip times for AIMD. So any questions as we do? Okay. Now let me do fast recovery, and we'll see how many round trip times this takes. So again we do exponential increase only the first time. So start with 1 packet, double it, again double it to 4, then double it to 8 packets. Now packet 10 is getting dropped, so congestion window is 8 packets, congestion threshold is half of 8, which is 4. So in fast recovery, what we do is we start from congestion threshold itself. So the next window you send 4 packets starting from 10, 11, 12, 13. So and then keep doing additive increase. So 4 packets, now 5 packets, 6 packets, now 7 packets. Then packet 25 is dropped. So congestion window is 7, half of that is the congestion threshold. So that means the next window you send starting from the congestion threshold of 3 packets, which means you send 25, 26 and 27. So again you always retransmit starting from the packet that got dropped. So 25, 26, 27, and then you send you do additive increase. So 4 packets, then 5 packets, which is and now 34 gets dropped. So you send your congestion window is 5, half of that is congestion threshold of 2. So that means you start with 2 packets as congestion threshold and then increase additively. So 3 packets, 4 packets, 5 packets. So you now have packet 45 getting dropped. So congestion window is 5 packets, half of that is 2, which is the congestion threshold. So in the next window send 45 and 46, 2 packets, then 3 packets. Now you could actually send 4 packets in the next round trip time, but you want to send only 50 packets, so you send the last packet in this last round trip time. So it takes 18 round trip times for sending 50 packets with fast recovery, which is even less than the 19 that you got for AIMD. So 50 packets times 1 kilobyte divided by 18 round trip times, each round trip time is 100 milliseconds. So you get a larger throughput, 227, compared to the previous two values of 195 something and 215 you got with the other two mechanisms. So these are the three congestion control mechanisms. So you should be able to do this for your exam. Okay, so I'll soon post it in a couple of days. You'll have time, so I'm going to give some more time for this exam. It's a bigger exam, so I'm going to make it due next Friday instead of next Thursday. So next Friday means it is what, 17th, by the end of that Friday. Okay, so again you should start working. You should not wait until the last minute because this exam will require you to do all these calculations by hand, and you have to be very careful. As you see, you have to watch out for the numbers carefully and decide how much you could send in each round trip time. Okay, so with this we finish this module. So again, if there are any questions, you can ask me.